Howdy Cal folks, it's Mr. Norman here. I'm going to go over an introduction, actually I guess it's more of a review of some linear concepts. So the first thing we're going to go over is coordinates. So first, this is the x-axis, it goes left and right. This is the y-axis, it goes up and down. So coordinates start with a parenthesis, a number, comma, another number. So as we can see, the first number is 2. So we're on the x-axis, 1, 2. The second number is 3. So we're going to go on the y-axis, 1, 2, 3. So we can put another point. Let's say it's point -2, comma 4. So -2, 1, 2, 4. 1, 2, 3, 4. So now that we have our coordinates, we can talk about slope. Slope, rise of the run. So typically slope is over a line. So we'll make a line. So we'll make a line between 2 points. And now we'll find the slope of them. To find slope, it's simply rise over run. So we're going to count how far up or down the rise one dot is from the other. So we'll count 1, 2, 3, 4, 5. Oh, I'm sorry. Lesson, folks. Always look at your scale. These notches are not for our scale. So this is here to here is 1 unit. So we're going to rise. Oh no, this is going down. So we'll fall, which means our slope will be -1. And we're going to run 1, 2, 3, 4. So our slope has a slope of 1 negative, because we're going down, 0.25, which is the same thing as y equals -1 divided by 4 plus 3.5. Ten points to Gryffindor if you can tell me what's wrong with this. I forgot the X. Now we see our line appear to disappear. It's because they're overlapping. Now it's red. Now it's black to show us the thing. So this brings us to our slope-intercept form. So in slope-intercept form, there we go. In slope-intercept form, y equals mx plus b. Hopefully this is familiar to all of you. M is the slope. X is a variable, y are variables. And b is our y-intercept. Intercept. So if we go back to what we had before, our y is here, our m, -1/4. As we counted, we went down 1 over 4. X, and this 3.5 is where the y-intercept, this is the y-axis, it's when the y-intercepts or crosses. The line crosses the y-intercept, as we can see here. So if we go to this example over here, we can figure out what our y equals mx plus b is. Always write y equals. So we'll pick 2 points where they cross well. This looks like a point, and this looks like a point. So we're going down, which means it'll be a negative. So we're going down 1, 2, 3, down 3 over 1. Always remember the x, and it touches the y at 1, 2. And we're going up, so it's plus 2. To clean that up, y equals negative 3x plus 2. Now if we look at the instructions here, it says find the slope. So our slope is negative 3. So if we look at this example, we have again y equals mx plus b. We have 2 points here and here. So we're going to rise 1. We're rising, so it's positive, over 1. So the slope is 1x. It touches the y at negative 1. So y equals x minus 1. So our answer is 1. To show another example, slightly different one. This is our axis. If our line goes straight up and down, Oh no, that is not the one. Oh, this is very bad. Let's see, I'll cheat. So this is our line. So we notice that it rises a lot, never stops rising, and it runs 0. So if we go from this point to this point, it's going to rise 2, and it runs 0. So y equals mx plus b. Wait a minute. We have 0 on the bottom. Can we do that? I don't think so. As my old college professor would say, if you put 0 on the bottom, you kill the dinosaurs. So what do we call an equation with 0 at the bottom? It's undefined. So we have an undefined slope. That should not be y. That should be slope. We also have a unique scenario when the slope goes sideways, like this. So from here to here, it rises 0 and it runs 1. What is 0 divided by anything? It's 0. So our slope equals 0. So now we're looking at this. We need to create a graph based off the equation. So number 4 says y equals negative x plus 2. Y equals negative x plus 2. draw our grid. This plus 2, remember, is our b, which equals the y-intercept. So that's where it touches the y, so we're going to go up 2, and this is a point on our graph. Our slope is -1, which means we're going to go down 1 over 1, down 1 over 1, down 1 over 1, and we'll draw our line. So to show you that that's a pretty good approximation, we'll type in the equation y equals negative x plus 2. And that looks just like mine, except for it's straighter and neater and prettier and orange. But the math checks out. So for this one, we have y equals 2, 5, y equals 2. So we need to graph this. So what's our y-intercept? Well, is there an x here? No. Which means we have 0 slope. That makes the 2 the y-intercept. So 1, 2. And what did it look like when the slope was 0 before? Flat. So that's our line. To confirm, we'll put y equals 2. Nice flat line. And the y-intercept is 2. Oh, guys, this is an important lesson, reading the instructions. 1 through 7 said to find the slope. I was sketching the graph. It's fine, the lessons still apply. No such thing as bad learning. So now we'll go to this one. We need to find the slope. So to have this, we need our formula to look like y equals mx plus b, where m and b are numbers. So that means we need to get y by itself. So how do we get y by itself? We go back to algebra class. So we move that. So we have 5y equals 7x minus 20. To finish getting y by itself, we divide by 5, which gives us y equals -7 over 5x minus 20 divided by 4. 20 divided by 5 is 4. So this will be our slope. So slope equals -7 over 5. And to show that that is correct, we'll go back to our app, 7x plus 5y minus 20. Seven x plus 5y minus 20. Got to zoom way out. A little cluttered. 7x plus 5y equals -20. And then we'll write the equation that we just worked out. -7 over 5x minus 4. -7 over 5x minus 4. And they overlap, they are the same. So we're almost done. We're going to cover one last example. This one's a little different. All of these have y's in them. This one does not. If we look back at an early example, we have y equals 2. And when we had y equals 2, the line was flat. There was no slope. If we look here, we have an undefined slope. We have an undefined slope. When the slope is undefined, we have a vertical line. I'll go back to GeoGebra. So let's do x equals 3. Let's do x equals 20 so we can see it. This means a vertical line goes up and down and crosses the x-axis at 20. So x equals 20. On the x-axis, the only number it can be is 20. It'll never be 40. It'll never be 0. Which means if we go back to our worksheet, x equals 2 means on the graph, if that's 1, that's 2, we have a nice vertical line. All right, Cal folks, that covers it for the day. I hope this was a nice review for you. If not, feel free to email me. Cowboys out. Peace.